Hi everyone, I'm teacher EJ. Welcome back to our YouTube channel. Today, I would like to talk about a past year question from NMOS 2019, which is about the Pythagorean theorem. Now everyone, let's have a look. So in the figure below, the square ABCD overlaps with the square CEFG. Both squares have the same area of 100 centimeters squared. Or you see, we have two squares over here. Given that the area of the hexagon ABCGFH is 125 centimeters squared, we are asked to find the length of DE. So you can see that DE is this part. So in this question, we are given with some area, we are asked to find what is the length of DE. So how do we want to solve this question? Alright, so now the first thing that we know in the question is that there is two squares that have the same area of 100 centimeters square, right? Okay. So we have the square ABCD over here and we have another square CEFG. Alright. So everyone, if we know that the area of the square is 100 centimeters square, what will be the side length? Oh, the side length will be equal to 10 centimeters. This is something that we can calculate. Now the next thing we know that the area of the hexagon ABCGFH is 125 centimeters square, which is this whole part right here, right? So this is the information that is given. Now everyone, let me ask you a question. For these two squares right here, we know the area. So if we sum them up, does it equal to the area of the whole figure given here, the 125? Oh, we say that it is not equal to it because there is one overlapping part. So which means that the total area of the two squares will be the total figure minus out the overlapping part. Right? So everyone, in this question right here, this overlapping part, how do we want to find it out? Oh, so we just have to add up the two squares, we minus out 125. We know that the overlapping part, the HECD, is 75 centimeters squared. But now that we know this 75 centimeters squared, what is something that we can do with this value? Okay, everyone, you see, the HECD here, this is a quadrature. Everyone, what if I try to cut it from H to C? Oh, now you can see that we obtain two triangles, and in fact, these two triangles, they are the right angle triangle. And you can see that these two triangles, they are actually identical. So from here, everyone, you can see that we want to find out DE. What is the relationship of DE with the triangle that we get here? Oh, we can see that DE right here is actually related to the height of the triangle. We say that the height of the triangle is just half of DE. Oh, so now, everyone, we know that there is a relationship between the triangle and the length of DE. We can try to use the relationship to find it out. So we know that the area of one right angle triangle, we know base times height divided by 2. So we have CH is the base, height is D2, the middle right here, and we have divided by 2. But in this case, we want to find out the value of the height right here. Do we have CH? Oh, we don't have CH. Do we have the area of HCD? Oh, we actually have the area of HCD. Everyone, because we know the area of HECD, and since we say that both of it, they are the same triangle. So everyone, to find out the area of HCD, you just have to use the 75 divided by 2. You have 37.5 centimeters squared. But now that we have the area, how do we want to find CH? How do we want to find the height? Now everyone, we say that we want to find out the value of CH. So before that, let me tell you something. Alright everyone, so to find out what is the value of CH, there is one very interesting concept right here that we can use to solve the question. So we call it the Pythagoras theorem. So the Pythagoras theorem says that when we have the right angle triangle, we say that these two right angle sides, the sum of square of it will be equal to the square of the hypotenuse. A squared plus B squared equal to C squared. We can use this theorem to solve this question. Everyone, which means that if we want to find out what is the value of CH right here, we need to know what will be HD and DC. Alright everyone, let's try to find out. But in this question right here, do we know the value of DC? We know this is the sine of the square. How about HD? How do we find out what is HD? Okay everyone, because we know that the area of the triangle HDC. Other than calculating the area of this triangle using the base has C and the height right here, we can also calculate the area in another way. Because this is a right angle triangle, so we know that HD times DC divided by 2 is also equal to 37.5. And in this case, we know the value of DC is just the side length, the 10 centimeter. So we can try to find out what is HD. So from here, we just have to use 37.5 times 2 divided by 10. We have 7.5 centimeter. And we know that HD squared plus DC squared is equal to CH squared. So we know that CH squared is equal to 7.5 squared for the HD and DC is 10 squared. So we try to calculate this, we will get that it is 156.25. Everyone, 156.25, this is CH squared. But we need to find out what is CH without the square. Alright, so to find out the exact value, we can use what we so-called the estimation method. Alright, we find the square of the number that is closest to our value right here. Think about it. For example, we can have 12 squared is 144. This is less than our result. And we can have 13 squared is 169. It is larger than that. Which means that our CH right here, it should be in between 12 and 13. And we can see that there is a 25 at the back. So if you try it out, you will see that it will be 12.5 squared equal to 156 and 25. So everyone, from here we know that CH is 12.5 centimeter. Alright? So everyone, now that we got the value of CH, we can try to find out what will be the height. Alright, so we say that the height right here, we just have to use 37.5 times 2 divided by 12.5. We get that it is equal to 6 centimeter. And just now we say that the height right here is half of DE. So to find out DE, you just have to use 6 times 2, which is equal to 12 centimeter. So this is our final answer. Alright, so let's summarize what we have learned from this question. So in this question, we apply one very important concept to solve this question. We say that we have this right angle triangle. The relationship right here, the theorem right here, we call it the Pythagorean theorem. So we know that A squared plus B squared equal to C squared. Or we can say that the sum or square of the two right angle sides is equal to the square of the hypotenuse right here. Alright? So now, you can try to do this practice question and you can leave your answer at the comment section below. Alright? You may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.